Hey there, how's it going? Fon here. Thanks for joining me. Today I would like to look at a subject which has been something I've been interested in for many years, but it's an unusual one. Let me run this idea by you. I believe that the numbers we use in music theory are, for want of a better word, actually incorrect. I believe that there is a better way to count the numbers in music theory, and I'm not the only person who thinks that. Link in description. Now, that's a massive claim that I'm making, a shocking claim. Yeah, I know. However, stick with me. I will attempt to explain as simply and quickly as possible what I'm talking about. And who knows, by the end of the video, you might even agree with me. So, how did this all come about? Well, many years ago, I was waiting to give a guitar lesson one evening, and I was just casually thinking about the word octave. This is an octave here, where you start on an E, you've reached another E, an octave higher. Octave is the Greek and Latin word for 8. So I was thinking, but there are clearly 12 notes in the octave, not 8. So shouldn't we be calling it a 12-tave? I Googled counting in 12s and was amazed to find the Dozenal Society of Great Britain and the Dozenal Society of America. And they believe that duodecimal is better than decimal. I was shocked when I discovered that. And then I looked at the possibility of, well, how does that fit in with music theory? And the answer is it ties in very well. In 10 base or decimal, counting your 1 and your 0 mean you've completed a cycle. An octave in music is also when you've completed a cycle. The E, an octave higher, is the same note, it's an E. So I was wondering, well, you've got your 8 base in music, you've got your 10 base in normal, counting your 1 and your 0, and lo and behold, in duodecimal counting, dozen is written 1, 0, which means you've completed one cycle and you're starting again, which is exactly what happens in the octave in music. So if you put it all together, 8, or in fact 12, and you count it in duodecimal, suddenly all of the little problems with musical counting disappear and you get one system that works absolutely perfectly. Let's look into it in a little more detail. So, what are the numbers that we use in music theory? We use the most popular number base in the world, which is decimal or 10 base. There are 10 digits or numbers or fingers. The word digit is finger and number, and most experts agree that that's why we humans chose 10 bases, simply because we have 10 fingers. No other reason. There are other possibilities. There are other number bases. So binary is 2 base, hexadecimal is 16 base. But the number base that I believe is far superior for counting music theory is duodecimal or dozenal or 12 base. The word decimal comes from early Greek and later on from Latin. In Greek, 10 is deca, and in Latin, it's decem. So decimal or 10 base comes from that root. The word duodecimal comes from early Greek and then Latin. In Greek, it would be dodeca, 2, 10, and in Latin, it would be duodecem, again, 2, 10. So just before we can start looking at music theory, first of all, we're going to have to take a little look at how duodecimal works. So obviously we're all very familiar with decimal, which I'm going to flash up on the screen now. Okay. Now let's have a little look at duodecimal or dozenal or 12 base. It's going to flash up on the screen now. So the way we pronounce this is O. 1, 2, 3, 4, 5, 6, 7, 8, 9, dec, L, do. Now, there are two interesting things here. Why do we call them dec, L, do? And what's going on with the symbols? Let's talk about the symbols first. X used to be used in Roman numerals or Latin numerals for 10. So it makes a lot of sense to use X for the 10. E obviously stands for 11. So it makes a lot of sense to use E for 11. 1 and 0 means the same thing that it means in decimal. What we mean when we go 1, 0 in decimal is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Start again, new cycle with a 1 and a 0. Okay, so when you start again in duodecimal, what we normally call 12 or 1 and 2, we call it 1 and 0 because what we mean is at this point we're starting a new cycle in exactly the same way that we mean it when we're in decimal. So that's the symbols. And just for the sake of interest, link in the description below to the Dozenal Society of America and the Dozenal Society of Great Britain. There are other systems of writing the 10 and the 11. Some use A and B, some use an upside down 2, and various other systems, but I think that honestly, I'm with the school of people who think that the X and the E and then the 1 and the 0 is perfectly correct. Let's take a very brief look at how duodecimal is actually superior to decimal for dividing into basic fractions. So if young kids were actually taught a bit of duodecimal in school, number one, it'd be interesting for them to know about other number bases. Number two, fractions are much easier. The Romans used the word inch, meaning a twelfth of a foot, and the original ounce was from the same root word uncia, or twelfth. So even though the Romans counted upwards in blocks of 10, the way we normally do, they found 10 was not very good at dividing and that 12 was much better. So when the Romans were dividing, they divided by 12. Imagine you had a birthday party coming up and you had a pie and you didn't know how many guests you were going to have. You were debating whether to cut your pie into 10 pieces or 12 pieces. All the most basic fractions in order are half, third, quarter, fifth, sixth, and so on. Let's take a quick look at that. If one guest arrives at your birthday party and you're splitting your pie into 2 pieces, fine. Your 10 pie, let's call it, has 2 divisions of 5. It can do that, no problem. And your 12 pie, let's call it that, has 2 divisions of 6. So you get 6 pieces each. Lovely. What happens if another guest arrives and you want to split your pie into 3 pieces? It's easy with the pie that's divided into 12. You just get 4 pieces each. But with your 10 pie, you get 3.33 or 3 1/3 pieces each. What if another guest arrives and you want to break it into quarters? Again, it's easy with your 12 pie, you just get 3 pieces each. But with your 10 pie, you get 2.5 or 2.5 pieces each. So we've done the half, the third, the quarter. Next up, the fifth. Your 10 pie is going to win. You get 2 pieces each. The sixth, the 12 pie is going to win. You get 2 pieces each. But my point is that out of your most basic fractions, half, third, quarter, 10 can only do the half. It can't do the third and the quarter properly, whereas your 12 base can. So if you're dividing anything into basic fractions, duodecimal always wins. So moving on, let's have a little look now at the music theory side of things. We use our decimal counting, however, we actually use 8 base in music theory. The most crucial piece of music theory is, in fact, the octave. This goes right back to the time of the great Greek philosopher Pythagoras, 500 BC, approximately. He discovered that one note sounds kind of the same to another note if it's double the frequency, like this. There are two C notes. Now, if you like a little bit of physics, the frequency of this note is going to be twice the frequency of that note. And if we go to a lower C, it's going to be half the frequency. What I mean by that is, let's take a different note, for example, an A note. Concert pitch is set at 440 Hertz for an A note. What that means is Hertz is cycles per second. So when you listen to an A, it's at 440 cycles per second. The next A up is going to be twice as many, 880. And your next A down is going to be 220. So there's the little bit of physics. So here we go with a standard C major scale. Here's our C note. You probably know this already, but the piano always has 2 blacks, 3 blacks, 2 blacks, 3 blacks. To find your C note, you always just go 1 to the left of any set of 2. That's a C, that's a C, that's a C, and so on. Anyway, so we're starting on C or Do or 1. Watch. Do, re, mi, fa, sol, la, ti, do. Also known as C, D, E, F, G, A, B, C. Also known as 1, 2, 3, 4, 5, 6, 7, 8. Incidentally, in Western music, we have a system called movable do, so we can call C do, but if we wanted, we could start on any other note that we wanted and call that do, so we can start in a D major scale. Do, D, do, re, mi, fa, sol, la, ti, do, E. Do, do, re, mi, fa, sol, la, ti, do, and so on. So what's the problem with the octave? Well, it's not actually 8 notes. Look, I just skipped over the black notes here. Look, the actual numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Start again. But if you were to count that in duodecimal, instead it becomes 0, 2. Do you see that? 0, 1, 2, 3, 4, 0, 2, 4, 5, 7, 9, 11, or L, and does or 12. 0, 2, 4, 5, 7, 9, 11, does. And that's the same if you were to look at that in the key of E on a guitar on the E string. That's exactly what you do, is open 2nd fret, 4th fret, 5th, 7th, 9th, 11th, 12th. Let's look at that on a guitar. Let's swap to the key of E. Let's do an E major scale on the guitar in the key of E on one string. Watch. Do, re, mi, fa, sol, la, ti, do. See how many frets I skipped over there? Skip, skip, don't skip, 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 don't skip. So that's the 8 notes, 1, 2, 3, 4, 5, 6, 7, 8. But in reality, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Start again. Okay, do you see why there's a problem? We're using 10-base decimal counting to describe an 8-base system which actually uses 12 notes. See why there's a problem? If we use duodecimal counting instead, and if we start on the O or 0, it becomes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, dec, L, start again, do or does or 12. So in standard music theory, C major is composed of root or 1, 3, and 5, and 8. Watch. Root or 1, 2, 3, 4, 5, 6, 7, 8. Octave. 1, 3, 5, octave. C, E, G, C is your C major chord. So if you wanted to number that instead with duodecimal system, the way you would do it is you would say O, 1, 2, 3, 4, O, 4, 5, 6, 7, O, 4, 7, and your 12 or do or does is the O, 4, 7, does, O, 4, 7, do. Similarly, if we were to convert this C major chord into a C minor chord, we drop the third to a flattened third here. So instead of being an E note, it's an E flat, which gives us our C minor. So normally you would say that it's 1 flattened third, fifth, and 8. But if you were to use duodecimal instead, it becomes O, 1, 2, 3. So O and 3 and 7 as it was, and 12 as it was, or do or does. Okay? So thank you very much for joining me. I hope you enjoyed that. If you're already a musician or a music professor, I hope you didn't find it too shocking. Have a think about what I'm saying. I'm not the only person who believes that this is the way forwards. I'm going to put links in the description to some of the other people who think that this is indeed the way forwards for music theory. So thank you very much for joining me. All the best. God bless. Bye.